So once again, we'll first rank the variable x in ascending order, that is from the rankings of 1 to 5, minus 10%, minus 5%, 30%, 45%, 50% return in the given years. For the same years, we will then note the returns that variable y gave and those corresponding ranks. So 15% was second in order, second lowest, 40% was fourth lowest, minus 20% in 2011 was the lowest, so on and so forth. 50% was the highest. Now you see there are 5 rankings for x and correspondingly 5 rankings for y. Hence, how many pairs of rankings will there be? Or rather, there are 5 pairs of rankings: the first pair, second pair, third pair, fourth pair, and the fifth pair. So there are 5 pairs, hence how many comparisons can be made amongst pairs? That will be 5C2, that is 10 pairs of pairs. Let's note down those 10 pairs of pairs first. So 1, 2 is the first pair, and let's note down all corresponding pairs with it. 2 and 4, 1, 2, 3 and 1, 1, 2, 4 and 3. This is one pair, second pair, third pair, fourth pair, fifth pair. So we are going to compare all with the other. Again 1, 2, 5 and 5. Let's start. 2, 4. Already compared it with 1 and 2, so no need to compare again. 3 and 1. 2, 4. 4 and 3. 2, 4. 5 and 5. Let's compare the remaining. 3, 1. Already compared with the other two in 2 and 4, so we'll compare it with 4 and 3 and 3, 1, 5 and 5. Just one comparison left, that is the comparison of 4 and 3 and 5 and 5. Now please remember, it will be called concordant if the difference or the direction of the rankings is similar. Discordant, never mind this, if the direction of the rankings is different. So let's see, and if there is an equality, then it will be neither concordant nor discordant. So let's see in this case, the first pair, is it concordant or discordant, or rather discordant? Concordant if it is corresponding. So 1 and 2 there is an increase, 2 and 4 also there is an increase, so this will be a concordant pair. 1 and 2 there is an increase, 3 and 1 there is a decrease, so there will be a discordant pair. 1 and 2 increase, 4 and 3 decrease, discordant pair. 1 and 2 increase, 5 and 5, it's an equality, so this will be neither concordant nor discordant. Understand? 2, 4, 3, 1, increase, decrease, will be discordant. Increase, decrease, discordant. Increase, equality, neither. Decrease, decrease, concordant. Decrease, equality, neither. Decrease, equality, neither. So we see how many concordant pairs are there? 1, 2. So we have 2 concordant pairs. How many discordant? 1, 2, 3, 4. 3, 4. 4 discordant pairs, and 1, 2, 3, 4, 4 which are neither. So we can tabulate these results. Remember, similar direction, you have to compare all the pairs amongst each other. All pairs, first you do the rankings like you did in the Spearman's correlation, then you compare all pairs of rankings with all other pairs, and you find out how many are concordant. Concordant if there is an increase together or a decrease together. Discordant if the direction is opposite, one increase, another decrease. And neither if there is equality present anywhere. If the same rank in any of the pairs, then it will be a case of neither concordant nor discordant. So we found out there were 2 concordant pairs, 4 discordant pairs, and 4 that were neither. So the Kendall's correlation is calculated as the number of concordant pairs minus the number of discordant pairs upon the total number of pairs, which is 10. So in this case it will be 2 minus 4 upon 10, that is minus 0.2. Please note, if all the pairs were concordant, this would have come out to be 1, 10 divided by 10. If all were discordant, this would have come out to be minus 1, that is minus 10 divided by 10. So in that respect, both Spearman's correlation as well as Kendall's tau is similar to the Pearson's correlation that we calculated earlier, which is the maximum and minimum values is +1 to -1. Both Kendall's T as well as Spearman's correlation are ordinal measures, that is, they only look at the rankings and they are non-parametric. We don't need any mean standard deviation to calculate. The Pearson's correlation was the covariance upon the product of the standard deviations, as we studied. So what are the limitations of the Kendall's T or the Spearman's rank correlation? That is the limitations of ordinal risk measures. So ordinal measures based on ranking are implemented to analyze the dependence of market prices and counterparty risk. Since ordinal numbers simply show the rank, problems arise when ordinal measures are used for cardinal observations which show the quantity, number, or the value of the observations. So in other words, what we're trying to say is that in the ordinal measures, it's just the rank that matters. Whether the return, actually the highest return was 50%, 100%, or 1000% would have made no difference to the Pearson's the Spearman's correlation or the Kendall's T. That is, if this last return, let's say in this case, was 500% instead of 50%, this actually came out to be 5000% or 500%. Even in that case, our calculation wouldn't have changed. So the ordinal measures ignore this cardinal nature of the data, or they ignore the actual values of the data. If that is not very important, then it's fine. Then it's okay, our ordinal measures will work fine. However, if that value or if that information is important, then the measures may not be the best thing to do, or may not be the best measures of risk. So there can be impact of outliers on ordinal measures. So assume that we triple the returns of X from the previous example to show the impact of outliers. If outliers are important sources of information and financial variables are cardinal, what are the implications for ordinal correlation measures? So even if we triple the returns from X, will the rankings change? Will the rankings of X change? All returns have been tripled. No. So will there be any impact? There will be no impact on either the Spearman's correlation or the Kendall's T. So the absolute numerical values are not important. It's only the rankings that matters. So outliers also will not have a value. So even if one, like I explained, that 5% or 50% are changed to 500 or 5000% even, that one last ranked value will still remain the last ranked value. Whether it was 50, 500, 5000, 50,000 makes no difference. So the ordinal measures in general ignore the impact of outliers, and they may underestimate the risk. If outliers are actually have value and that information should have been incorporated, then it is not being incorporated by the ordinal measures. So those were some other types of or additional data, and we studied other measures of calculating correlation and some of the limitations. One last limitation that we'll study of the Kendall's T before we wind up is that if there are a large number of pairs that are neither concordant or discordant, then the calculation can be distorted. So if there are only a few, see, concordance essentially implies a positive correlation. Discordant implies a negative correlation, and neither we are ignoring basically. So if that's neither concordant nor discordant, then what we are assuming is that that does not impact our correlation, or is that means a no correlation. So for example, there were 4 pairs which were neither concordant nor discordant. So somebody can interpret that Kendall's T was only based on 6 out of the 10 observations. So it was using only 60% of the observations to actually calculate the correlation. 40% were ignored as irrelevant because they were neither concordant nor discordant. That is, some information is being lost in the methodology that is being used by the Kendall's tau. So that was the next review or on understanding correlation better and understanding certain other measures, limitations of financial models, limitation of correlation, certain other methods of calculating correlation, and other perspectives on correlation. We studied the Pearson's correlation, measured or understood that it's a linear measure, and we looked at more ordinal measures which looked at the ranking rather than just a Pearson's correlation, and we studied the limitations of those measures as well. So just the session enhanced our understanding of correlation and the understanding of risk, and there'll be one more session that we'll study on correlation before we wind up the review on financial correlations and the impact on risk. So thanks a lot, and see you next time.